Everyone. So we're going to talk today best practices of software development. That is what we're going to talk. Hold on for a second, please. So let's begin, guys. Best practices of software development. So that is the subject and topic I want to talk to you about today. And talking about software development best practices. Now, in software development best practices, when we look what we are trying to develop and evolve, there are certain best practices of accomplishing. As I mentioned yesterday, there are a lot of development which we do, a lot of methodologies we use, a lot of approaches we use. They are subject to many parameters. They are subject to many best practices. There has to be some rationale for it. So there has to be some reason for what we are doing, So if you look at here, symptoms, root cause, best practices. Symptoms, as we know, what we are observing. Root cause basically talks about what we are observing, what is behind that. That is the root cause. And then, what are the software development best practices to accomplish that? So for that we have symptoms, root causes, and best practices. Three things: symptoms, root causes, and best practices. So, for example, we have modules do not fit. Modules do not fit basically means that a standard SAP module which is being provided, that does not fit. If that is the case, if that is the root symptom, if that is what is happening, then, and we have modules don't fit basically means we have a standard SAP, and then in SAP we do not have various parameters, and in these parameters our current SAP solution does not fit. And the reason could be that it is very complex. The requirements are very complex. And for those reasons, there may be a degree of complexity. Okay. So that is an example of overwhelming complexity. Now, what are the best practices to develop in such scenario? So, number one, we do model visually. That basically means you do unified modeling. You continuously verify the quality, making sure the solution works as needed, as expected. So these are some of the software development best practices. Practice one, develop iteratively. Develop iteratively in iterations. And you can have a various iterations of your requirements. Now on those iterations, you can manage requirements. You can have various use component architectures. You create a UML to continuously testing it, managing changes as they come to you. When we talk about waterfall development characteristic, this is waterfall characteristics. So you have a requirement. For the requirement, you have a design. You do coding and testing. You do integration. You system test. Go live. That is a classical waterfall approach we talked about, and this is we talked about is used in mostly complex projects. If you look into SAP implementation, waterfall is pretty commonly used in case of SAP implementation as well. So it's a very commonly used approach in most implementations, especially in SAP world. This is another view of iterative development product executable. So you plan. Yes, it is a step-by-step, yes. So you plan, understand requirement, analyze design, implement, test, deploy, evaluate. So if you look at this flow diagram, this should be part of a DNA. If you look into any software development, at the end of the day, this is what you end up doing. Planning, understanding requirement, analyzing, designing, implementing solution, developing solution, coding solution, testing it, and then after testing, we put the deployment, and after that, we do continuously keep doing evaluation. That is iterative development executives. It's a very common cycle which we use. Manage requirement. In software development processes, and when we are doing software development, among all the different things which we do, our ability to manage business requirements is probably the most critical. Our ability to understand the business requirement, our ability to manage scope, So one part is understanding it, one part documenting it, is one part is that we have got validations. But what happens in the real world after you have the requirement? There is a constant array of changes. There is a constant new inclusions. And because of that, we always have and we always require this ability to manage requirements properly. And because of this requirement management, possibly is one of the most interesting, most important, most critical business requirement as far as the business requirements are concerned. So manage business requirements. Now, what is the requirement management basically means? Making sure solving the right problem and making sure we are building the right system. Give me a second, guys. Okay, requirement management. This is what I was talking to you about. Now, requirement management basically means making sure that we are solving the right problem and we are building the right system. We are not going to a business requirement which is irrelevant, business requirement which is not critical to the business, business requirement which are least important. Okay, so that is the requirement. Now, also important is taking a systematic approach. Now, systematic approach to getting business requirement, organizing the requirement sessions, workshops, doing a proper documentation, and after documentation, you are managing and keeping track of the scope correctly. One of the things which is changing requirements of a software application, business requirement keep changing, but that's one of the biggest challenge. because if the business requirement keeps changing, then it is very difficult to manage the timeline, manage the project. So it's become very, very challenging. So it must be, in all cases, avoided to the extent possible. Map of territory. So I have a business requirement. Hold on for a second, guys. I'm getting another phone call. I'm back, guys. Is my voice coming to you all? Can you guys all hear my voice clearly?
Yes, sir, we can hear you.
Wonderful. Okay, good. I'm not in the class. I hope you guys are not missing me so too much. Oh, well. We are crying. I can see there is a water level up in New Jersey. Yeah, Kiran, I know, is crying. I know. Okay, wonderful. Don't cry. It's just that I have many end-to-end calls, so I just cannot step out. Unfortunately, my life is not as good as you guys are. But nevertheless, do not miss me. I'm just a telephone call away. I don't know if I will be coming today, though, because I have another call after that and I have to do a few other things. So it's just crazy busy day. Okay, so let's continue with our conversation on this slide. Map of territory. So problem is space, solution is space. In the problem, we identify business requirements. In the solution, we basically see what different features we require. Traceability. A lot of people use this term called traceability. I would like you guys to make a note of that term called traceability. In some of the real world, it's also called business requirement traceability. Business requirement traceability metrics. Or also called BRTM. Business requirement metrics is nothing but business Excel sheet which has the various business requirements mentioned into it. In fact, every business requirement that you capture is individually tracked. Every business requirement is uniquely identified. And identified, tracked with the solution. So making sure that every requirement is identified, tracked, and making sure there is a solution developed for it. It is tested, so people can do a complete follow-up. Yeah. So that is business requirement traceability metrics. So then we create a software Test script. This is another word which you will be seeing that you guys have to make a note. That's called test script. Test script is basically steps how testing would be done. And people write a specific test scripts. People write test script and they do the testing for those test script, those test steps. So this is an example of a test script. In that test script, we write down all its steps. This is a business scenario ID. So requirement is being tracked. This is a step, this transaction code, what is the input, what was expected result, what was actual result, which team is testing, who's the tester, what was the result found, whether it's pass and fail. And then it go through all the scenarios, all these steps. These are all various steps in one scenario. This is an example of a actual test script, which you can see. So this is an example of a test script. Can we call it a QC? The testing is quality control here, but a script is the steps. So that is the test script. Now, another example is use cases. Here we have something called use cases. Use cases. Use cases are the list of business requirements which are being tested. Use case, as I mentioned, that every business requirement is uniquely identified. Therefore, for all business requirement, each business requirement which is uniquely tested is a use case. There's another terminology which is being used pretty commonly in the real world: use cases. Okay. Use case model. In the use case model, there is a requirement. So we get all business requirements as we want. For these, and then for these requirements, we do the realization. There is a design model. Design model basically means tell that how this business requirement will be realized. Means how many tables, what kind of program, what is the database, all of them. Then we do the actual writing the code, which is source code. We do test a script, whether it's a pass or not, and verify, then circle continue. Use case as a basis for system modeling. So basically at the end of the day, when we are testing, but use case is nothing but basically the scenario which you are testing. That is the use case. That is example of a use case. That is where the use case being used. That is a context and scenario of the use case. Use case as a basis of the test planning. So when we are creating a test scenario, which a test script, which I showed it to you a few minutes back, then that test scenario is being written on the basis of use case. Use case means business, uniquely identified business requirement. So for that business requirement, we have a use case, and for that use case, we have a test script, and then we have a test scenario, test case, or test step for that. So test cases, test script synonym. Test step is a step in the script, and then one script can have a multiple steps. And hold that step together is one scenario and one test script. Use component architecture. The component architecture basically means the model should be reusable. The whole concept of component-based architecture. Make a note of this term called component-based architecture. Component-based architecture. Component-based architecture. What does component architecture basically means? What does it do for us? Component-based architecture basically is architecture in the bricks. Architecture which is reusable. Architecture which can go into the steps. That is an example of component-based architecture. Component-based architecture. In component-based architecture, we can, when we are doing the planning, project management, staffing, delivery, everything is done on the basis of components. So in developing this particular software, what all different components we require. So if you look at here, so there is application component, business requirement, middleware, and program. So program talking to middleware, middleware have a business requirement. For the business requirement, we have application. These are various components of an architecture. Similar to when we talk in SAP world, we talk about a three-layer architecture. The three-layer architecture is basically nothing but component-based architecture, where each of the element is uniquely separate and reusable and reconfigurable with each other. So component-based architecture. Model visually. One language for all practitioners. Talking about one language for all practitioners. So we have a business modeling, requirement modeling, application modeling, technology modeling, data modeling. Make a note of these terms. Business modeling, requirement modeling, application modeling, technology modeling, data modeling. That is an example of a UML, Unified Modeling Language. Let us understand that. But before that, make a note of these terms. Business modeling, requirement modeling, application modeling, technology modeling, data modeling. Business modeling, it talks about various business process scenarios. I would sales order processing, delivery processing, invoice processing, quotation processing, purchase order processing, in which we are giving a process flow diagram, a process flow representation of the business requirements. That is called business modeling. Requirement modeling is a one step further. In that, basically, we are talking about the explicit business components, process steps. So if you look at this diagram, this is a process step level. So in order for this business requirement, so requirement is a subset and one step further or one step down of the business modeling. And then we have application modeling. When we talk application modeling, basically means we are talking about program, the behavior of the program, the flow of the program. And technology modeling basically means when we are talking about various components of the technology. For example, program A is talking to program B. Application A is talking to application B. And between the application A and application B, there is also middleware. And this is how these two middleware talk to each other. So technology modeling. Now, data modeling is about the data, master data elements, for example. So for example, customer master, or material master, or vendor master, product master. Now, how those data would be structured, maintained, and consist of? That is example of a data modeling. That is what data modeling do. So we have that data modeling. So these are some of the, this is also called unified modeling languages, in which every component is being used for all practitioners. So this is for business people, this is for BAs or business analysts, this is for programmers, this is for system architects, and this is for master data managers. So for different people working on a project, performing different activities, these are their different process models for their practice. The role of UML in RUP. So RUP means Rational Unified Process, was developed based hand in hand with the UML. UML means Unified Modeling Language. Make a note of this term, UML. You will be hearing that term called Unified Modeling Language. Unified Modeling Language. That is called UML. Okay. Continuously verify your software quality. This is important statement. Software problems are 100 to 1000 times more costly to find and repair after deployment. So once the software has been deployed, implemented already, then the finding a solution for that problem and solution at that time is much more costly, because solution you have already deployed and now you're making change to it, making amend to it, repairing it. So once you deploy, cost goes very high. Therefore, it is critically important to do the proper software quality, do a proper software quality based upon your business requirements, making sure that all positive, negative tests is being done, making sure we are perform all various type of tests and verification as we discussed. Because once you deploy, then it's very costly. Now, we talked about briefly that when we are talking about testing, so what we test. So first and foremost, we look from the functionality perspective, which basically means all of these various business requirements which you have expected system to do, whether those business requirements the system is capable of doing or not, or doing if there is an issue with that. Usability basically means ease of use, convenience. Software is working fine, but is highly cumbersome. User experience is not very comfortable. It's not easy to use. Reliability, that application is constant. It's not making a dump, it's not falling down. So it's a constantly working in a very predictable manner. Okay. So that is an example of reliability. Another thing which is very important is performance, often ignored. That we have to make sure that the performance of the software is correct, means how many users can log into the system concurrently or not. So example of performance. It must perform well. It must be supportable. There's the ability to maintain and support application under production use. It should not be a highly complex system. So once we go live, once we deploy, it is not usable anymore because it's so cumbersome and it's so complex and it's so difficult to manage and maintain. Test each iteration. When in testing, see the iteration 1, iteration 2 is straight, iteration 3 is iteration 4. Now, this word iteration in real world we also call cycle. Cycle 1, cycle 2, cycle 3. I don't know whether you guys noticed when I was showing you that test script. So see here, this is cycle 1, cycle 2, cycle 3. So or iterations. We use synonym. So iteration 1, iteration 2, iteration 3, iteration 4. So you don't only test it something once. It is very common practice in the real world to test an application and system multiple times, in multiple cycles, multiple iterations. Okay, so that is an example of a iteration and example of a cycle. Cycle 1, cycle 2, cycle 3, cycle 4. Change request management. Make a note of this term called change request management. This is another very important statement. Change request management. Now, what is a change request? Change request basically is once you have formed the business requirement, once we have confirmed documented, validated business requirement. Okay, this is what is our total business requirement is about. This is what we will be doing. Unfortunately, though, but it does happen that those business requirements constantly keep changing, or new requirements keep coming. And because of that, we have to create a change request. Change request is a formal process in which you would also see that we are testing the application multitude of time and making sure that those change requests are understood, those change requests are approved, those change requests have been understood with an impact perspective. Remember, every change request you incorporate, there is impact of that. If you get a new requirement, it might change your live date. It might require 2 more weeks, 3 more weeks. It might require additional work. It might require additional resource. It is possible that we may not be able to do the project on the time which we have stipulated. Okay. Okay. Change request management. Change requests could be of various levels. Okay. Those are the change requests. Okay. Now everything is connected. Everything end to end is connected. Ensure users are involved, requirements are evolved, architecture decision made early on, business design has been done proper, implementation is done in steps incrementally. We are continuously qualifying, verifying, testing, and evolving your baseline solution incrementally. Best practices of software development life cycle. Some of these are very important indeed. Talking about the rational unified processes, some of the best practice: develop iteratively, manage requirement properly, use component architecture, model visually, UML. We talk about the 5 of them. Continuously verify and perform the quality and manage changes. Bring it all together. The iterative approach. Phase 1, phase 2, phase 3, phase 4. Make sure you do business requirement gathering, analyze, design, implementation, test, development, if any change, project management, environment, all of them going together. Working, bringing it all together. Working together in harmony. This is important. Slide. Is a collaborative working. Changing focus of phase over the time. Okay. When we're doing in the beginning, the scope and business cases are agreed, architecture is understood, product has been developed, product has been accepted. Inception, elaboration, construction, transition. And then there are multiple iterations which goes along with each of these steps. There are multiple iterations which goes along with each of the stages. multiple iterations, which goes along with all these multiple iterations. Okay. At the end of the day, is a team effort. Typical effort and time percentage by phase. Planning phase, initial phase, maybe 5 to 10%. Understanding business requirement document could be 20 to 30%. Most of the time goes into the construction. So 60 to 70% time plus minus goes into the building and constructing the solution. The remaining 5 to 10% time goes into transition. In SAP world also, this is very true. If you talk about 1 year project, 12-month project, you will find that 60-70% of the time goes into construction, 20 to 30% goes into business blueprinting, 5% before, 5% transition. That makes the total 100% of the time in terms of different phases of implementation, whether it's any software or SAP for that matter. Okay, so that was our slide, and that concludes our presentation for today. And I thank you for coming in, and look forward to talking with you tomorrow. Thanks, guys. Bye.